Hello everyone. Assalamu alaikum. I am Sakline from Group 6 and my ID is 143. I along with my project partners are here to present our project of electrical service design course. Our project is basically a three-storied building design with proper electrical equipment connection diagram with conduits and fittings. If we look at the ground floor plan of our project, there are basically 5 allocated areas, which are a parking area of 2,288 square feet, a guard room, and a driver room with attached bathroom facility. 14 feet by 18 feet area is allocated separately for both kitchen and a storeroom. If we move on, the first and second floor plan, then we will see that at the entrance of the floor, there are 2 units per floor. Each unit consists of one master bedroom of 16 feet by 20 feet with a veranda and an attached bathroom facility. Two common conventional bedroom of 280 square feet without attached bathroom facility, one common bathroom, one kitchen, as well as drawing room and a dining room. This is the first and second floor plan of our project with detailed information. Here go some symbols with proper diagrams which are used in AutoCAD drawing of our project. My following partner will describe the calculation procedure of different measurements.
Here we have measured the number of lights using this formula of illuminance, where the number of lights per illuminate is set 1 by default and the multiplication of light loss factor and utilization factor is set 0.72. And we have used this formula to calculate the number of fans. Next. For example, for a room of area 320 square feet, we got the number of lights 2.64. So we needed 3 lights and 3 fans as per the calculation. But to preserve power consumption, we have set 2 lights and 1 fan for this room.
These are the fittings and fixtures for the ground floor. There are 9 switchboards. We have used a combination of tube lights, energy bulbs, and incandescent light bulbs. If we take a look at the parking space, 19 energy lights have been spread out all over the ceiling according to the determined calculations. In the kitchen, a tube light has been placed along with an exhaust fan. There is a 5 ampere socket in the switchboard as well as a 15 ampere socket because larger loads such as refrigerators are usually placed in the kitchen. In a similar manner, we have placed lights, fans, and sockets in the bedrooms, storeroom, and bathrooms as well. This is a summary of all fittings and fixtures in the ground floor. This is the conduit diagram. The main distribution board is near the staircase, which is connected to the generator and a single sub-distribution board that runs the entire floor. 5 circuits in total are connected to the sub-distribution board, with a total of 9 switchboards. Some of the switchboards and loads are connected through the same conduit, and the conduit sizes are determined by the diameter of wires that will be inside. For example, in the parking space, C3 is needed for the 3 lights LS1, LS2, and LS3. After LS3, C2 is needed, and finally, C1 has been used to connect to LS1. For the 15 ampere socket in the kitchen, a larger conduit size, C9, is required.
These are the fitting and fixtures of first and second floor. There is one sub-distributional board in the center and 10 switchboard in each unit. We use different combination of light and fans for different size room according to their purposes as per calculation. Like in this dining space, there is one big fan, 2 types of light, 2 P and Q, 3 pin. As they are rated for higher current, 15 ampere and 20 ampere, they are usually used for fridge and oven. This is a summary of electrical appliances in this two floor. Uh, this is the conduit diagram. We can see C6 wire is used for a switchboard. Two switchboard need C7 and P&Q requires C9 and C11 for higher current rating.
Project. My student ID is 1606189 and I'm showing the calculation of for all the switchboards and SDB MDB for ground floor and first and second floor. Here first we seeing the calculation for switchboards. Here we see all the currents are below 5 amperes, so 1.5 RMB YM and 1.5 BOI ECC wire are used. In this way, we calculated all the switchboards and emergency switchboards for ground floor, first and second floor, and the corresponding wire size are given in these tables. Now we are in the calculation for SDB for ground floor. Here total SDB load is 1622 watt, so corresponding SDB current is 9.16 ampere. So a 10 ampere FCMCCB is needed from SDB to MDB, and 22.5 RMPY plus 2.5 BY ECC where is necessary here. In the same way, ESDB ground floor calculation is done, wire size is given here. Now we are in the calculation for EMDB. Here we see total MDB load is 3794.35 and corresponding current is 12.45 ampere. So 15 ampere TPMCC is needed from EMDB to MDB. And here 4 into 4 RM NYY plus 4 RM BYACC wire is necessary. And finally, we're in the calculation for MDB. Total MDB load is 26,343.205 watt. Here pump load is 5,000 watt. So MDB current is 86.41 ampere, and here 100 ampere TPMCCB is required from MDB to the main line. 4 into 70 RM NYY plus 70 BY ECC is used here.
The switchboard diagram has 5 circuits. This is done based on the conduit diagram of the ground floor. The green line represents normal wire connection, while red line represents emergency line connection. Circuit 1 comprises of guard room and kitchen room. Circuit 2 represents driver room and store room. Circuit 3 comprises of staircase and pavement, whereas Circuit 4 and Circuit 5 represents left parking spot and right parking spot. Next, emergency switchboard diagram is also done by the same way. The circuits are represented by Circuit 1 prime, Circuit 2 prime, Circuit 3 prime, Circuit 4 prime, and Circuit 5 prime. Next. In the subdivision board diagram, the line from the Circuit 1, Circuit 2, Circuit 3, Circuit 4, and Circuit 5 are sent to the subdivision board, and from subdivision board, the line goes to the main distribution board. Next. Similarly, in the emergency subdistribution board diagram, the lines from the emergency switchboard diagrams, they enter the emergency subdivision board diagram, and from that they go to the main distribution line.
This is the switchboard diagram for one unit of the total 4 units in the first and second floor of the building. We have divided this into 10 switchboards and 4 circuit connections. The first circuit is from bedroom 1 and 2. The next one is from balcony, second bathroom, and kitchen. The third one is from bedroom 3 and bathroom 1. And finally, the last circuit is from the drawing and dining room. This is the emergency switchboard diagram, and all the emergency lights and fans are connected to this. These circuit connections are named CKT1 prime, CKT2 prime, and so on. Since we are using combined switchboards for normal and emergency case, the switchboards are named the same. Here we can see all the circuits going to the sub-distribution board for the unit, along with 5 15 ampere sockets and 3 20 ampere sockets. The sub-distribution board then connects to the main distribution board. Finally, we see all the emergency circuits going to the emergency sub-distribution board, which itself connects to the emergency main distribution board.
Here we can see the main distribution board diagram. We found that MDB current is 86.41 ampere. So 100 ampere TPMCCB is needed. And so 4 into 70 RM NYY plus 35 RM BY ECC cable is required. Also, we can see EMDB is connected to MDB through a 4 into 16 RM NYY plus 16 RM BY ECC cable. And a pump of 5 kilowatt goes straight to MDB through 4 into 2.5 RM NYY plus 2.5 RM BY ECC cable. For EMDB, we get 12.45 ampere EMDB current, which leads us to 15 ampere TPMCCB. So we need 4 into 4 RM NYY plus 4 RM BY ECC cable. Thank you.